All right, so the final. There used to actually be two finals. So if you see that in this, you'll see that in the study guide. There is the query statement exam. You don't need to worry about this one. This one's been removed, so you don't need to worry about that one. We're just going to be doing the vocabulary exam, and you'll notice like this is kind of what the vocabulary exam works. It says what subquery is known as an expression and returns only one column and one row. And then you would type the single word that would precede query or subquery to label it in lowercase. So that's kind of what the format's going to be. There should be a couple practice exams on there to get you familiar with it, but really it's just fill in the blank. Spelling does count. There are a few cases where it'll give you a little leeway, and most of the time it's all lowercase, or it'll say to type it in lowercase. Yeah, all the questions will be fill in the blank. Because there used to be this one right here, but that one's been taken out. So I'm actually just going to delete that for right now so we don't see it. All right. So what I would do to study for the test, which I've done for a while, that seems to have worked well for students, is actually go through just terms and understand them. And for a lot of these, it should be pretty, it should be mostly review. But we're going to go through it just to make sure. And I think that's the best way because it's nice. And what I would do as, because we won't hit all these, but we're going to hit some of the ones that maybe weren't quite they weren't quite as big in labs. We're going to hit those pretty hard. But if I were me, what I actually did a lot for my master's and other studying is I would do this. I would just take these terms and I would make my own notes. So you should have this in a docx format so you can edit it. You know, there was one time I was on a flight for 4 hours and I actually just, with my Apple Pencil, I just hand wrote my notes. I would also keep track of where you found the information that you're jotting down. The exam is open book, open notes. So you can do all that, you know, make sure you keep track of where you found it in case you ever need to go back to it. Yes, yep, should be the same one in the link. The only difference is I just deleted the final exam piece of it, but really there isn't too much difference. Even when we had the final query exam, we still just studied this because it's just helpful. All right, so we're going to just kind of dive right in. If you have a question, feel free to throw it in the chat. And we'll just jump right in here. So just so you know, I have McLaughlin's website up on the right over here. And then I have my study guide. I'm not actually going to write on my study guide. We're just going to kind of go over it and talk about a few things. And yeah, we're just going to dive right in. Make sure you kind of understand most of this. And a lot of this will be review. So we're going to start with bullet point number 1. What is SQL? What does it stand for? And it stands for Structured Query Language. And the reason I have McLaughlin's website up over here is because it is very useful. It has this little search feature there. And you can search for various things, and a lot of times it'll find it. Sometimes it's not as great. You can also use Google to search for the various components. But yeah. So we're just going to kind of take a look at this. All right. So the first couple things. So SQL, what does it stand for? Structured Query Language. Nothing too crazy there. Quick Google search will find that one for you. DDL. So we're going to talk a lot about what these different categories of SQL statements are, and some stuff inside. So you'll notice that we'll have these a lot down here, but I like to go over the different categories because you are going to get questions about DDL, DML, DCL. So I definitely want to talk about it. So the first one, let's start with DDL, Data Definition Language. And I really like this page here for this because it has links to them all. So data definition language. And the way I like to remember this is because it defines things. Because there's really two parts, and we've seen this in our labs. When we create a table, we are defining data. You know, does our data have a first name? Does it have a last name? what size do we let the first name and last name be? We're defining our data. We're not actually creating any data. We're defining what the data is going to be. So data definition, it defines things. And so when we look at the DDL statements, they are create, alter, drop, rename, truncate, and comment. Now, like I said, most of this should be reviewed because we've seen most of these in our work, like create, alter, drop, rename. We haven't really seen too much with truncate and delete. So truncate will delete data. So it's just like a delete from. We used delete from before, but our delete from will delete data. But the only difference is it prefers it deletes the content without logging. So, and this is actually a pretty big, not that you're going to get this on the exam. This is just for an FYI. One of the most common database related interview questions is actually what's the difference between a delete and truncate? And the big one is that delete can be rolled back. So, for example, if I say begin transaction, or if I do a save point, remember we used a save point where we talked about how we can always roll back. If I said save point, right? And then I deleted all of my data from, let's say, my item table. And let's say I said, oh, whoa, I didn't want to delete all my data from my item table. We could then roll back that transaction. And that works with a delete. But if we said truncate, item, we're going to delete things out of there and we can't bring it back. So truncate's one of those that you're going to rarely use. But I don't even know if you'll see it on the exam, but just so you're aware and you know what it is. Then we have this comment, and a comment lets you add a comment about a table or column in a specific table. So when we say you can add a comment, and really it's just a note for other developers. So like, let's say you have a field in your table, or let's say just our item table. We could put a comment there and say this table holds the data for movies and items. And then we could put a comment on item title and say, this is the title of the movie or the subtitle, whatever. We can add comments so that when people are then looking and saying, oh, what does this table do? There's a comment that'll kind of let them know, which is really handy when you get into databases that are massive. So like the database that I work with most days has well over 200 tables. You can imagine that it becomes very handy to have those comments. So that's a DDL. And like I said, the main thing is it defines things. We're changing the structure. And I know I've said this before, but if you think about a house, when you first build a house, you build the structure, and it defines what rooms there are and how big those rooms are. And that's kind of the structure. And that's our data definition language, is that building of the house, or when we change a house. Now, once the house is built, someone moves in, and that's where we get into data manipulation language. And data manipulation language is how we handle what's inside of the structure. So DDL is used to create the structure or alter the structure, where DML, we're going to deal with what's inside. So for example, if we have data, we can run select statements to see what's there. We can do insert statements to actually put things in. We can use an update statement to update things in the database, the actual data. So I guess just to compare, if you need another example between DML and DDL, alter and update are very similar in syntax, I guess you could say. Alter changes the structure, while update changes the contents. So for example, if we're going back to our house analogy, if I wanted to add a room to my house, I could say alter house add room, or something like that. In our case, in case of a database, it would be add a column. But we're going to say alter house add room. Where the update would be, let's say that we wanted to add a new couch to our house or change the color of the couch in our house. We could say update couch set color equal to, something like that. So update is going to affect data inside. And that's kind of how I keep those in line. If it changes the table or the structure, it's DDL. If it changes what's inside, it's DML. Or if it handles what's inside. So for example, our select, we're dealing with the data inside, we're querying it. We can put data in with the insert. We can update the data. We can delete data out. Now remember, truncate, there's a big difference. Truncate cannot be rolled back. It handles the deletion on a very different level. Delete will go through and kind of delete on a row by row basis, whereas truncate kind of just wipes it out. And then the merge, we did a merge in lab 11. And the merge is where it's just like an insert and update combined. We can kind of choose. So obviously that deals with the data inside. All right, and we used a lot of those. We used DML and DDL all the time. So there shouldn't be anything new as far as those. We'll get down to them later, maybe hit on them individually in just a minute. But we're going to talk about some of the ones that we didn't quite do as much. So DCL, which is data control language. And data control language is basically we're going to control who has access. So if it has to do with controlling who has access to the data, then it is data controller, DCL. And really it's grant. So here's some examples of the DCL command: grant and revoke. And that's really all you need to remember. Is grant and revoke. And it's just how we give access to, I guess here's a more comprehensive list. Grant and revoke is, I'm pretty sure, all you're going to see. But the DCL commands, grant, deny, and revoke. So if I wanted to give someone access to a table, so that's what's kind of nice. In the class, we only saw, we never really saw this because we would just go on and we would log in as our student user, right? And that's because we already have access. But let's say you're in a big business environment. Let's say that there's like 4 of you all working on the same project. You might have access to some tables and some not. So for example, in government, you have different tiers of security clearances. So let's say you have an entry-level database tech engineer. He might only have access to the tables that don't have the secret confidential stuff about aliens, for example. Whereas your top tier database engineer, he has access to the table about UFO sightings and aliens and communication logs with aliens or something. Sorry, I'm going off. But anyways, so in that case, we would use a grant command. So for example, here's a great example. If we say grant, we can actually specify specific things. So let's grant select, insert, update, delete on employee, which is our database or table, to user 1. Okay, so pretty simple. So if you're giving permissions, you're going to use grant. If you're taking away permissions, you're going to revoke in that kind of case. And then deny is where you explicitly ban some privileges. So, all right, and those can get kind of crazy, but I think that's as much as you need to know is grant and revoke for those. So DCL, data control language, and it deals with permissions. It controls the data as far as who has access. That's how I remember those. So DDL is the structure. DML, data manipulation, is we're changing what's inside. Data control language is we're controlling who has access or who can do what. We're very controlling. That's like kind of what when I was taking my certs, that's what I always would say. I'm very controlling. So I'm giving people access and revoking access. And then the last one is our transaction control language. And we talked about this just a second ago, but that is our save point transaction type stuff. Let's see, this is let's just go look at Oracle Tcl statements. All right. So here is our Tcl statements. We have these further down here, I believe. Save point right here, transactions. So I like to remember this as transactions. And when you think of a transaction, think of like a bank where things are kind of all or nothing. You know, you put your money in and it kind of all happens and that's kind of where a lot of this came from, is because when we're dealing with money, things have to be very much controlled and safe. And transactions are just ways that we bulk commit things or we don't. Because, for example, if we're transferring money from one account to another, and which happens in databases quite frequently, you want it to be a thing where you say, look, begin a save point, because we don't want money to be lost in the middle of nowhere. You can imagine what it would be like if you said, oh, you know, I'm gonna buy something, right, with my credit card. So you have money in your account, you go to the store and you go to checkout and it charges your card. And let's say on the database end, it doesn't have transaction control language. Let's say that it's programmed in such a way that it pulls your money out. But let's say somewhere in the middle of that whole thing, someone is out digging a hole and hits the network cable and something goes wrong. Well, at that point, you just lost your money. So yeah, that's not good. Where the transaction control would come in is it says, look, begin a save point. So we have your value, your money. And then we're going to try to move your stuff. And if something goes wrong, we're going to roll back and it's like it never happened. So Breton asked, so we start a transaction with save point. We can either accept the changes with commit or revert changes with rollback. Correct. Yep. And not both. Because once you either commit or roll back a transaction, it's done. Yeah, which is kind of so you just want to be extra sure. So I'll tell you a very good time. I actually use transactions almost with everything. And the reason being is because if you ever do a boo-boo. So for example, there's one time where I'm going to change, there might have been a student or someone, and I'm going to change their schedule. And what I want to do is I just want to completely wipe out their schedule, their move-in. So something went wrong with the system. So I was just going to go in and clear it all out. Well, I actually, in haste, forgot to put a where clause. So I just said delete everything from schedule. Or, you know, that's not the actual table name, but essentially what I did. And it actually ended up wiping out everybody's schedule. Now, if I hadn't been using transact statements, I would have had to then go through a whole shut everything down and go through a data recovery process, which is very expensive. If you're a database person, that is the last thing you want to do. It's really embarrassing. So I always use transact statements. So when I did that, I was expecting to delete, you know, like 13 rows of data. Well, I realized what I had done because all of a sudden I deleted like hundreds of thousands of rows. And I'm like, whoops, my bad. And so then I just very quickly, before anyone knew anything, said roll back, and rolled it back. And it was like it never happened. And people never have to know. It's just our little secret. So so yeah, just like Breton said, the way this works is you start out, and like in that case, when I'm going to do something, I say begin transaction, or save point. So I say save point. It creates a point in your transaction to which you can roll back to. So I create a save point. I do my work, and then what I usually do. So let's say I do something, I'll go and check. So I'll write some select statements. And I'll say, okay, did everything I do work properly? If so, commit. If something went wrong, roll back. And like he said, you can't do a commit and then roll back. Once you commit, it is permanent. Yes, rollback closes the save point. That's kind of the idea of a transaction, is when you create a transaction, anything you do from there on out is part of that transaction. And then once you either commit or roll back, it affects everything in that transaction. So So yeah, once you commit or roll back, that save point is now gone, and then you have to create a new save point. And there's a lot of reason why that is, which we could go into. It's really has to do with the what's called the redo buffer log. And there's some good articles about here, but the redo logs are filled with redo. Basically, it knows what happened. And so basically, if you imagine like a giant carousel, every time you do a statement, it adds that to the carousel, and then you can kind of just roll it back like one of those old dial phones, if that makes sense. It's out of the scope of the class, but it's called the redo buffer log is what is really responsible for all this. All right, let's go take a look at what's next. So that's kind of our main stuff. And so all of our statements that we're going to talk about from here on out fall within one of these categories. So, you might want to put what category these are in as you go down through it. All right, so select statements. Let's talk about select statements, because select statements are kind of the bread and butter of SQL, if you haven't noticed. And there are some very important things. Now, on the query exam, it used to be very important to cover order of operations, and I'm still going to do that because I think it's huge. I think if you can understand order of operations, you're going to be that much. It can help you solve a lot of problems, because you might get questions about certain things, and if you know the way that a select statement is executed, you can solve the problem. You might not, have the answer memorized, but you can work through it. So the select statement is a couple different. It can have a lot of different clauses, but a select statement in general requires select and a from. Everything else beyond that is optional. So, we can have a basic select statement, select everything from item. Then we can add a filter. So we filter the rows. So we say select everything from item where item title like Star Wars, and then we only get Star Wars movies. Then further, we can add a group by clause. And, we don't have to have a where clause. We could have select everything from item with a group by clause. But the group by is required if you have an aggregate function, which is a fancy word for adding, averaging, counting, or calculating a value. And the way that I like to think of aggregate functions is, and if you look up the word aggregate definition, that's kind of a cheesy thing to do, is to actually look up. And let's look at that. To collect or gather into a mass or whole, to amount to, whole sum, or total. And so really when we talk about aggregate, I like to think about it that we're taking many into one. So like if we say, let's say that in a table, we have a bunch of transaction, a bunch of money. Just like, let's say you go to the grocery store. Every time they scan something, like let's say they scan your chicken noodle soup can, they scan your milk carton, and they scan a candy bar. All those things are going to be rows in a database because they keep track of purchases. And so from there, they need to get a total, which they might put into an overall thing. And so if they wanted to say, okay, from these purchases, what is the total? They would need to use a sum. And essentially what they're doing is they're taking those three rows, your milk, your chicken noodle soup, and your candy bar, and they're going to compress that into one row that has a total. So that way it basically has your credit card and the total, your account number and the total. So when you think of aggregate, just know that we're taking many rows and squishing them down. Somehow we're either adding or averaging or counting into one. Another great example of a group by is if you, in school, we take multiple classes. And so if we want to figure out what our overall GPA is for the term, we take our grades and we convert those to a GPA. So like if we have an A, it's 4.0. A minus is like a 3.8, blah, blah, blah. And we take those, all of those, and we average them. And that's our GPA for the term. But at the end of the day, we have one row at the end. And so basically we have to tell the computer, how do we want to group this? Because it has to know where we condense the information down. And so that's what the group by does. And we've done this a lot in the lab, so it shouldn't be anything new. But if you have an aggregate function, you will need a group by clause. And I just did something wrong. Let's go back here. So if you have an aggregate function, you need a group by clause. That's something you want to remember. All right, and then if you have a group by clause, it unlocks this having clause. And the having clause is basically the where clause for the group by, if that makes sense. Because let's say we say group by the average GPA. Or let's say we're averaging the GPA. So we have our group by. So let's say I want the student number and their average GPA. So I would say select last name, or let's select student number, comma, average GPA from course GPA, something like that. And we would say group by student number, because that's what we want to condense on, because obviously it's going to condense all the GPA. So we just got to tell it, look, we want to group the GPA by the student number. And then let's say that we want to only find people that have above a 3.8. It's like, let's say we're giving out scholarships. So we would say group by student number having average GPA greater than or equal to 3.8. So that's where the having comes in, it is tied directly to the group by clause. And then last but not least is the order by. And the reason order by is at the last is because it really doesn't have any effect on how the data is collected or any actual function, other than it just changes how it's output. And the reason why this is somewhat, I guess, iffy, because a lot of people, they'll just spit it out. They'll spit out the data and they have their data and then they sort it in Excel. But the order by is nice because we can kind of pre-sort for them. So we've all used order by a lot. So when we actually go to decide how this works, and I'm just going to go very to the last one, because really, if we know how it works with all of them, then we can filter down from there.
Brother Crew?
Yeah.
When you do the select statement, does it matter? I know that if you have a select statement that you have to, from, right? Select and select and from. The rest of them, the where, the and, group by, and order by. Does it have to go according to the order that is there, or can you put like order by, under, after, from, or can you change it, or does it be this order right here?
They have to be in that order.
Okay.
Yep. Good question though. Yep. They have to be in that order. Which is kind of funny because and we'll talk why, because really the bottom half of a select statement is in order. But the first part's not. So we're going to talk a little bit about this, and I'm going to try and explain it logically, because it just makes sense. And I'm going to explain it in a way, because what I really like about SQL language is it just makes sense. It's very logical. And I guess my perfect analogy is if you had to find data out of a filing cabinet, we wouldn't have to train someone how to find data out of a filing cabinet. But for whatever reason, trying to find data out of a database all of a sudden makes things overly complicated, and it doesn't necessarily need to be. So I'm going to use that example here quite a bit. So the first thing that when we run a select statement, when we write it, the first thing we write is the select with our columns, like we see here, what data we want to see. But that's not actually how the computer works. So logically, if someone said, I need to get some data. Let's say you work in a library and you need to find information about a book. And libraries used to be very keen on their indexing systems. So let's say, oh, I need you to find this folder that's in this filing cabinet in the archives on this book. So you say, okay. And they might give you a sheet and tell you, or you're looking for it. They don't know exactly where it is, but you do know what filing cabinet it starts with, which is kind of the big thing. So the first thing you're going to want to do is go to that specific filing cabinet, or in this case, what table, because that's kind of where it all starts. So we say, okay, the first thing the computer is going to do is look at the from clause and say, okay, where am I pulling this data from? And so then we would go there and get all the data. So in this case, we're going to go up to the filing cabinet and we're going to take a look at it, right? We have the filing cabinet sitting in front of us. For the computer, it actually loads it all into RAM. Then the second thing it does is it says where. And so at this point, we're going to start filtering down because we have all the data. Now we need to start filtering it down. So then we're going to say, okay, where the book title is, or the book author is Brandon Sanderson. So we're going to go and look, and maybe the drawers are ordered or whatever. It's irrelevant. Let's say there's just one cabinet. So then we open the cabinet and we're looking for where the author is Brandon Sanderson. So let's say all the Brandon Sanderson books are there. We pull out the stack. Brandon Sanderson's got quite the library. So we pull out the big, tall stack of folders, all with Brandon Sanderson's books. And then we might have to filter that down more. So like in this case, an and clause. And let's say we are looking where it's Brandon Sanderson and the title is Rhythm of War. So then we would go and look. So the where clause is actually all inclusive. So when we say and, as long as it comes after the where clause, it's still technically the where clause. So like in this example here, the where and the and are both part of the where clause. So then we could find our stuff. And then from there, we group by if we have an aggregate function. So in this case, count. So let's say we're going back to our example. Let's say we weren't looking for a specific book. Let's say we were just seeing how many books Brandon Sanderson had. So then we would take and we would count those, and we would group them by we would group them by the I keep wanting to say artist, but it's the author. We would group it by the author. And then lastly, we would, then we would sort them if we wanted. And then the very last thing we do is we actually choose what we want out of it. So let's say we were gathering some folders or some papers out of those folders. Then at that point, we would actually take out what papers we want out of the folders. Because basically through all these steps, we have everything, we have all the data. It's all there. And the very last step is, what do we actually want to see? Now that we've got it all sorted, we've got everything figured out. Now let's just show the data that we actually care about. And that's why the select statement runs last. All right, and Josephine asks, where do we use the on? And the on is actually part of the from clause. So in this from clause, if you have joins, so you're probably asking because you've seen a lot where it's like we say from item I, inner join, rental item, RI, on I dot item ID is equal to RI dot item ID. So that on clause is all part of the from. So if you do a join, if you have a join in your query, that all runs first. It actually goes through and connects all the data and gathers that first. So if you use the on clause, it will always be in the from statement, which will run first. Because basically the first step is gather all the data. So the on clause is in the from statement. So this is a nice little page if you want to remember how this works. It's really good. All right, while we're here, I'm actually going to jump just a little bit down here to our subqueries because it's right here. So subqueries, there are 4 types of subqueries. A scalar subquery returns only one column and one row. And if you remember right, there's this nice little question up here that says, what subquery known as an expression and returns only one column and one row? So for this sample question right here, it would be, you would type in scalar. because it says, please type the single word that would precede subquery to label it in lowercase. So you would just type scalar just like it is right here, just the one word. So just scalar. All right, so let's talk about those other ones. So a scalar subquery would be like when we're doing an insert. I'm sure we all saw them when we would do the insert for created by, last updated by. You know, we would say select system user ID from system user where system user name is equal to sysadmin. That returns only one column and one row. So basically a single value. And that's why I think this was listed first. It's the most popular. Because most of the time when you're writing a subquery, you're doing it to pull a single value, or in this case, one row and one column. A single row subquery returns one row with two or more columns. And so let's say you're trying to, let's say you're doing an insert that already has a bunch of data. You could pull a single row and do an insert that way. A multiple row subquery returns two or more rows with two or more columns. And then, so those ones are pretty easy to remember. You know, you're basically pulling, then this one you're pulling a singular list, and this one you're pulling a list of lists, if that makes sense to you programmers out there. And then a correlated subquery includes a join between the subquery and the outer statement, but returns no values to the outer statement. So a correlated subquery is where you actually kind of do a join. And by join, and I think we do a correlated subquery. Let's actually just pull up an example here, one that's really good. Subquery example. Let's pull one up here. All right, so let's take a look at this. So this would be, yeah, this is a great example of a correlated subquery. So here we have our outer query, right? The outer is the one that's on the outside. And then here, so basically we're selecting all this information about employees, but then we have this subquery right here, and we select the average salary from employees. Now let's see, that's not a great example of a correlated subquery because they don't do join. I guess it does join because it does it from, let's see, where does this work? A really good example. Let's see if we can find a better example. Here we go. This one's better. So let's take a look at this one. So here we can see that we select like the last name, employee information. And in this case, we're giving it an alias of outer. And the reason we're giving it an alias of outer is to show that the correlated, it's the outer query. Then this is our inner subquery here. And you can see that we select the average salary from employees, but we connect them. And this is where it joins. And we say where department ID is equal to the outer dot department ID. So basically we're getting the average salary of all the employees per department. And basically whatever the department is here, we're actually going to get their salary from this. So this outer dot department ID and this department ID will match. So that way we don't get the average salary for the whole company per every department. We actually get the average salary per department. Does that make sense to everybody? Correlated subquery?
Yes, sir.
Perfect. And the nice thing about the vocabulary exam is you're not starting from scratch. You know, there'll be some clues within the question. So what's nice is as long as you have some quick notes jotted down, it should be pretty easy to, should be easier, I should say, to kind of make educated guesses. And believe it or not, that's actually most of the stuff we haven't seen, or the tricky stuff. So we're going to move a little faster because I don't want to sit here and go on and on about stuff that we've done quite frequently. So the update statement, we're updating data, we're going to change data. So like if I want to change my last name in the database to Baggins, I would say update person set last name equal to Baggins, where last name is equal to Crook, something like that. An insert, obviously we're inserting data. No need to go crazy there. A delete, and we talked a lot about this. The delete statement will delete, but it can be rolled back. That's the big key. The delete statement can be rolled back. And then truncate. Truncate will delete stuff, but can't be rolled back. Create statement will create things. Now you can create a table, you can create a view, you can create a sequence, you can create an index, so on and so forth. So create statement. Drop, same thing. Create and drop are anti each other. So whatever you create, you can drop. And the drop actually deletes the structure. And so, yeah, that's the drop. And then alter. Alter is how we change structures or things. And we've seen that quite a bit as well. All right. And then tables. And I hope everyone knows what columns and rows are. I'm not going to cover those. I think we should all have a pretty good idea there. The primary key. I think we should all have a pretty good understanding primary key. And someone asked if the exam is open note. And the answer is yes, it is open note. So primary key is the primary key of the table, which is defined when you create the table. A foreign key is a connection to another table. So for example, if I'm in address and every address is connected to a contact, the contact ID in the address table is a foreign key. It doesn't belong. That's how I like to think about it. What is the one thing? Because when we're talking about addresses, where everything in there looks good. We have address ID, street, street address, state, country, that kind of stuff. But then we have this one thing that's kind of all on its own, that should be in another table, the contact ID. Well, the reason it's there is so we can connect an address to something, and that's why it's foreign. It's the foreign key. It's the one time that we should duplicate data because that's how we connect things. If we didn't duplicate the key, we wouldn't be able to. So foreign key is the reference to another table. That's how we build relationships in our relational database, the primary and foreign key combinations. And then an index. What is an index? And let's talk about an index for a little bit. An index is something we can build or create, which we've done plenty of times. For example, we might build a unique index. And in fact, a primary key is inherently a unique index. And there's lots of different types of indexes, but an index is just, we define it and it lets the computer know certain things about it. So for example, if we create a unique index on email, so let's say we have a database table for users. So we're just going to say the user table, and let's say there's an email column inside that table. We can create a unique index on email, and that will make it so there's no possible way that an email could exist twice in our system, which is pretty common. Because most of the time people don't change, or two people aren't going to have the same email address, and you don't want them to have the same email address, especially if you use it for authentication, which we do. So unique index on email. And then the reason why we use indexes, and this is where we get into database tuning and performance, because let's say that you do a lot of querying based on email address, which is pretty common, or username. Let's just say email and username are the same thing in this case. So what we would do is when the computer goes through, let's say your Facebook, it's going to have to search through millions and millions of rows to try to find your email, to find your specific record for your user. Well, if it knows that there's a unique index on email, as soon as it finds it, it doesn't have to keep looking. So let's say that you're the fifth one. Let's say you were the fifth person to sign up for Facebook. It's going to find yours and it's going to say, okay, I found it. I don't need to load any more rows. I already found it. So that's where tuning comes in, because the index will help it be faster based on different things. The other thing index can do, so another great example is we have a database at my work where we track who is on the guest Wi-Fi network. Based on, they have to sign up kind of to get on the guest Wi-Fi network, and we keep track of that. And so we have a lot of rows there, obviously lots of people signing up to get on the guest network. And so we put an index, not even a unique index, because in this case, it would break our system, but we put an index on the timestamp that they signed up. And then what that does is it tells the database to sort. It does a lot of black magic on the back end, but basically it sorts the data. It keeps indexes. So let's say that you're trying to find who signed into the guest network in the month of November 2020. Well, it already has those kind of segmented out, so it doesn't have to necessarily go through all the records in that table. It will just go to the chunk that was for November 2020. So like timestamps, things like that. If you're dealing with last names, alphabetized stuff. So if you're looking for a last name of Crook, it'll just jump straight to the C's. It doesn't have to necessarily go through all of them. So index is performance and tuning. Sequences, we use these quite a bit. Next val will return the next value, and cur val will return the current value in a sequence. We should have had a lot of practice with that, so I'm not going to go over that too much. We talked a ton about transactions, but just to sum up again, it's just like a video game. You're getting ready to go in the dungeon to fight the boss, so you manually save, right? Because you don't want to. You want to start from there every time. So then you walk in the dungeon, and if you win, you commit. If you lose, you want to roll back, right? And sequences are actually objects. So you wouldn't really have a sequence in a DML or anything like that, but your create sequence would be DDL. So sequences are just like tables, just like a table isn't a DML or DDL. It's just kind of an object. The actual syntax you use to create it and manipulate it will depend on what you're doing. So in this case, sequences, you can assume that they're DDL statements because they're more of a structure rather than or an object rather than the actual data within it. So it'd actually be more like DDL. Because with sequences, really you're doing like create sequence, drop sequence kind of stuff. Good question though. All right, and then our joins. And again, I don't want to get too crazy with this, but I'm going to highly recommend that you keep this with your notes. Keep one of these handy. They're very, very useful. Just to go over them again, the inner is only going to return results that have matches. So for example, if we have a contact in a telephone table like ours, and let's say that I don't have a telephone. If I'm a contact, but I don't have a telephone record and we do an inner join, I'm not going to show up at all. Right. And sometimes a lot of times that's what you want. So for example, let's say we're writing a script that will automatically send text messages to people in the company. So let's say, we're just keeping that all up to date. We want to do an inner join because if they don't have a telephone number, it might throw an error on the other system. We don't know, but there's no reason to return someone who doesn't have a telephone number if that's what you're doing. So inner join, matches only. A left join in that same scenario, I would be returned because it doesn't matter if I have a telephone number or not. It would return me regardless. An example of this question for SQL joins, it might say something like, what type of join will return matches only, or something similar. And in that case, we'd use something like an inner join. And, you know, it might have a picture of this diagram and you have to say what kind of join it is. For example, it'll say, you know, what type of join is depicted in the diagram above. And then you have to pick. That's probably more common. So inner, left, and right is just like left, but it just depends on the order of the table. So let's say we did a right join. It's going to return everybody who has a telephone, but not the other way around. So left and right are the same thing, just flopped. So for example, if we did select everything from telephone, right join, contact, then it's the same thing as select everything from contact, left join, telephone. So left and right are kind of weird that way, but it's just nice because you can order things the way you want. A full join will return everything, whether they have a match or not. So full join will return everything. A cross join, and this is the one that you kind of need to be aware of. The cross join will return the Cartesian product, and that's an important thing to remember. Cartesian product, and I'm actually going to pull this up here. Two table joins. So this is another good page. It's two table joins, and you can then click on these. But let's take a look at cross join because this one's really interesting. So you'll notice that this one is actually multiplying, and that's called the Cartesian product, which is multiplication. Basically, you're going to multiply everything. So like if we have I think there's an example here. Let's take a look. So like if, for example, we were doing like a table that would have English and French, and we cross joined it, we would get 1, 2, 3, 4, 5, 6, and they would all say un, and we would repeat that for un, deux, trois, quatre, cinq, six, so on and so forth. So you're going to get the times. So if there's 2 tables in A, or if there's 2 records in A and 2 in B, it's going to be 2 times 2 to get the total number of records that you're going to get. So that's the cross join, multiplication or Cartesian product. And then our outer join, they don't list an outer join here. An outer join is just the non-matches. So if you wanted to find all the non-matches, so on and so forth. And I have full listed twice on the study guide. I just realized that. A natural join. Let's take a look at it. All right, so our natural join is where we have something that's already kind of predefined. So our using clause. And I think I don't know if we ever talked about a using clause since they did the rework of the courses. So you may or may not see this at all. But basically, instead of using an on clause, so for example, here's our inner join. And we say, you know, we want to join on, and we say how they match. The other way to do an inner join is using this using clause. So if they have the same name, but that's the key, they've got to have the same name. You can use this using clause, which isn't a big deal. It just uses the same name. But with a natural join, if they have the same name and it's defined, you don't even have to specify. You can see here, we just say select everything from vehicle V, natural join, work order, WO, and it just knows. So that's a natural join. Not too crazy. You won't see those very often. All right. Oh, and then one last thing, union, intersect, and minus. Those are ones that we don't see very frequently, so I forgot those earlier. So let's take a look at those. Union, intersect, and minus. So we're going to take a look at this. Let's try intersect. All right. So let's start with intersect. Let's start with union, actually. Sorry, I'm going to go back. So a union, so when we do a join, we combine tables horizontally, right? So we're going to take, if we want to get contacts and telephone numbers, we're going to see their names, and then in the same row, their telephone numbers. Well, what if we want to stack multiple queries together? So when we do a union, what we're actually going to do is we're going to stack multiple records, multiple queries on top of each other. So here we can see that we're selecting some translations. So we get one query first, right? So one and un probably, and then we're going to connect them. Basically, it's going to, let's see if we can find a better example. Let's try this. All right, so let's take out this for right now. We're going to take out the bottom half of that query. So if I select city from customers, I get these rows all the way down to Walla. Notice I get 91 records. If I put this back in, we're going to add to the list. So now we're not only going to get city from customers, we're going to get city from suppliers. And you'll notice that now I have 94 because we added those on top. So let's say that, here's a good example. Let's say that you want a list of people who are taking CIT225 and CIT230. We could then say, okay, select everything from roster where course is equal to CIT225. And then we could say union, select everything from roster where course is equal to CIT230. And that would give us all of the records horizontally. Now we could just have a where clause, but sometimes you're selecting from, because we could do some fancy stuff here, but sometimes joins won't let you work. Maybe they're not joined at all. Like, so for example, maybe customers and suppliers aren't connected in any way. And we just want to see all the cities that we have in our database. So that's where the union come in. And then Brett asked a good question. If we use union all, will we see the duplicates? So yes, the union all will show you, it's an unfiltered join that returns 2 copies of the intersection plus the symmetric difference of all. So basically a union all is going to show you all listings. If you do a union, it's going to filter out duplicates. So like in this case, where we have a union from city and city, it's going to change it. So let's actually try union all. Notice if we use union all, we get 120 records. If we do a union, we get 94. And that's because our union all is showing us everything. So we probably have some duplicates in here. So for example, because we're ordering this, so we can find the duplicates. So here's Buenos Aires is actually 3 times. But let's actually just take this out and say union. And then we go back here and look. You'll notice that Buenos Aires is only returned once. So union is going to filter out the duplicates, just like the distinct clause. A union all is going to show everything. It's not going to filter out duplicates at all. Good question. All right, and then let's talk about an intersect. So we just talked about it, you know, how that works with the union all. So let's say we do want to see which ones are duplicate. Now we kind of did that just by going through and looking and finding where there was multiple. But let's say we want to actually see intersect. So if we actually want to see which ones where they intersect, we can actually go and take a look. So between the city from suppliers and customers, we can see that the ones they have in common are Berlin, Montreal, Paris, and Sao Paulo. So let's actually just take this out. So let's just verify. So city from suppliers, we should see Berlin, Sao Paulo. So if we want to see where they intersect or where they overlap, we can do so like that. And that one's really handy too. So to go back to our example with people, let's say we want to know what students are taking CIT 225 and CIT 230 at the same time. We would use intersect, right? Intersect. What do they have in common between the two queries? And then the last thing is a minus. And minus, as you can imagine, is going to take the first one and subtract anything that's in the second one. So Berlin, Montreal, Paris, and I don't know how to say that. They won't be in the list anymore. Let's make sure I did this right. Minus. And sometimes they're different because this probably uses some other thing. Let's try minus. Sql minus. Because I'm trying to think what the other word is that the other databases use. Except, that's what it is. So let's try this. Just know that that's pretty much the same thing as minus. There we go. So we shouldn't see Berlin, which we don't, or any of those others. Basically, we're only seeing city from customers. And if there was a city and suppliers there, we're not seeing it either where they matched. So just like basic math, we're more minusing. And there's probably some good examples. I wish these were stacked the other way because really it's query A and query B vertical. So the way I like to keep those separated is the union, intersect, and minus are vertical manipulations, not horizontal like the joins. When we join things, we're dealing horizontal. With a union, intersect, and minus, we're stacking or subtracting vertically with the number of rows. Let's see if I can draw. That's not what I wanted. I think I can whiteboard. Let's just get, we'll just use this page right here. Okay, let's annotate. And let's draw with a skinny line. So what I mean by vertical and horizontal. So when we do a join, let's say we take contact. Right, we have our contact rows. Let's just say first name and last name. First. Sorry, I'm terrible drawing with the mouse. And then we join. So then we take a join. And when we join, we connect the telephone table horizontally across this axis. And then we might have something like a number, telephone number. So that's horizontal. When we do a union, for example, it's vertical, meaning that let's say we select last and first. Last, first. And let's select last first from contact. I'm just going to put from C. So this is our contact table. Select. Contact. Right? And then we union. Oh, that's terrible. Union. And we're going to union that with a transaction upload. Sorry, this is painful. So this is our contact tables, and we have a last name, first name, and then we're going to do the same thing with the other one. And we're going to stack them like this because we're unioning them. We're making the list longer. It's all the same data. last and first. But see, this one is vertical. Up and down is vertical. Across is horizontal. Does that help at all?
Yes, that is, I like that example. Thanks.
Perfect. Yep. Just wish I had a better, I guess I could have just made a new page on here. Oh, well. But yeah, and in fact, you can try it if you want. So if we were actually to open up VMware Player, we could actually, oh, and I'm still drawing apparently. Okay, let's stop annotating. We can test it, and I think that's like the really nice thing, because we didn't do too much of the union stuff. So I'll just show you a quick couple examples here real fast. So if we're looking at, let's just do that same example with transaction upload and contact. So if I select last name, comma, first name from contact, and we get those people. And then if I select last name, and this one will be a lot bigger, first name from transaction upload, we'll get a lot. But at the end of the day, it's the same data. So let's start with just a union. Actually, let's do a union all. Let's select last name, first name from contact, union, select last name, first name from transaction upload. Now, with the union, we're going to get it filtered, right? We only see them once, but we so realistically we get the same number of rows. But essentially, we're just stacking the data. But to show you a better example, let's do select last name, first name, contact, union all, select last name, first name from transaction upload. We're going to get a lot of rows because it's no longer filtering. But we basically just took all the results and we stacked them. So you can see how we're building a longer list. And that's kind of what I like to think about it. Union, intersect, and minus, we're changing the list. We're changing the vertical list. We can add to the list, we can take away, just like Santa's list. You know, we can add, subtract. But when we do joins, let's use the same thing here. And I think we do it on last name, first name, and all that kind of stuff. So let's give him aliases real quick. So let's select C on C dot first name is equal to TU dot first name So we're still going to get a lot of rows, but the difference is, let's stop that. Let's try that again. Let's say where last name is equal to Moss, and let's change one more thing. We're gonna just get the, instead of getting all the data, we're gonna get just the names. So we're gonna select C dot last name, C dot first name, TU dot last name, TU dot first name. And we're going to change this to distinct just so it's not as long. Oh, and I guess I need to say C dot. There we go. So you can see in this case, we're going vertical, where before we would stack these with the union, we would have them stacked. In this case, we have them straight across. So we can do the exact same thing with the union. Select last name, first name, contact. So you can see that we're just building a list instead of, you can see it's going vertical versus horizontal. All right. That's we've covered all of the statements that's in the guide. Is there anything that anyone wants to ask? Anything in addition to? From my feedback that I've had from previous semesters, it really just it covers most of it. And Brent asked, so like adding fields in the row versus adding more rows. Exactly. Yep. Exactly. When you do a join, you're adding more fields per row or horizontal. If you're doing a union, you're going to add more rows to the output essentially, but they have to match the same columns. I want to say there's 50 questions on the exam. I'd have to look. It does have it on Canvas. 25. Okay. 25. That shouldn't be too bad. Perfect. Well, all right. If there's no more questions, I will let you guys, I guess, start studying. This will be the last meeting of the term, though. So this will probably be the last time you hear from me, as far as I'd say face to face, but voice. It'll probably be the last time you hear from me. So yeah, Merry Christmas. Have a great break. I do truly wish you all the best. And yeah, great luck on your finals. Not only in my class, all the way across the board. Good luck.
Thank you, Brother Crew.
Yep, no problem.